All right, good morning, everyone. Looks like it is time. So, what are we trying to learn today? Today, we are going to be using what we have been learning, which is factoring. And we're going to take factoring, and it's a method to solve a quadratic. Now, what does it mean to solve a quadratic? That tells us the x-intercepts. And so, factoring is just one of the many methods to find the solution, and it's usually the most efficient. However, everything does not factor, or sometimes it factors, but not enough. And so before I teach you how to solve by factoring, I thought it would be useful to review factoring really fast. So this is what we've gone over the last two class periods. And the first thing you should always look for when you're factoring is a GCF. So again, we will go through these relatively fast. So we're going to review factoring, and then I'm going to show you how to solve by factoring. And then I will also show you how to solve by graphing. And graphing is actually pretty easy, especially if you have Desmos. So on A, I look at this and I say GCF is 3 because 3 goes into 3, 3 goes into 9. So I factor it out. And then what am I left with? I'm left with an x because 3 times x is 3x. And then I'm left with a 3 because 3 times 3 is 9. So the first thing you always look for is GCF. On B, I have 15 and 25. The greatest number that goes into 15 and 25 is 5. I also notice they both have a minimum of 1x. And then from there, I divide out 5x. So what is 15x divided by 5x? What is 25x squared divided by 5x? I like to think in terms of multiplication, so I think 5x times what is 15x, that'd be 3. 5x times what is 25x squared, that'd be 5x. Okay, now C, this is what we call a higher degree polynomial. And the reason why it's called higher degree is because this is not a quadratic. This is what we call a quartic. And so when I look at this, I see that they both have a minimum of x squared. This has an x squared, this has an x squared. So I factor out the x squared, and then I'm left with, that's a really strange parenthesis, I'm left with x squared minus 7. And you could actually factor x squared minus 7. You could factor it as difference of two squares. So you could write it as x plus square root of 7. And then x minus square root of 7. I know I didn't show you that, but if this number is not a perfect square, you can just use square roots. It's kind of like a trick. Okay. I want to make sure we save time for everything. So these other two I'm going to go through really fast. GCF is 9 for 9 and 18. X cubed and x squared is x squared. And that would be leaving an x plus a 2. And again, this is review. And then E, when I look at E, they all don't have x's, but they each have a 2. So I can take out the 2, leaving x cubed minus 4x squared. Oops. That's going to be 2x squared. And then 2 times 4 is 8. So that is a 2. Because 2 times 2 is 4. So that was the first thing we covered together, is how do you do GCF? The next thing we covered was difference of two squares. So if you have a square and a square with the minus, they factor into this. So x squared minus 64 would factor into x plus 8. x minus 8. X squared minus 144 would factor into x plus 12, x minus 12. And again, all of this is review from the last couple days. 16x squared, 4 times 4 is 16, 9 times 9 is 81, x times x is x squared. So this would be 4x plus 9, 4x minus 9. And then finally, we have 10x and 10x, 3y and 3y. So this would be 10x plus 3y, 10x minus 3y. But I think those are the easiest, in my personal opinion. We also talked about what do you do when you could do product sum factoring, but it only works when a is 1. So like notice 1x squared, 1x squared, 1x squared, 1x squared. And all you do is you find the two terms which multiply to the third term, but add to the second. So you say, okay, what multiplies to 15? Adds to 8. That'd be 5 and 3. So you say x plus 5, x plus 3. What multiplies to 30 and adds to negative 11? That'd be negative 5 and negative 6. So you get x minus 5, x minus 6. What multiplies to negative 9 but adds to negative 8? Negative 9 and 1. And then finally, what multiplies to negative 18 but adds to 3? Six and negative 3. So when a is 1 and there are trinomials, it's actually pretty simple. Okay, finally, the last thing I need to review, and again, this is all review until we get to today's lesson. And the notes I have here call it bottoms up factoring. I've never seen it written like that. But this is for trinomials where a is not 1. So you factor out the GCF. You should always look for GCF. You multiply the first and the last numbers. So you take 6 times 4, you get 24. And then you find two numbers that multiply. Oh, well, they've left off this step. Then you put the 11 on the bottom. And you find two numbers that multiply to 24 but add to 11. That'd be 8 and 3. And then you write two factors as fractions over the a term. So you'd get x plus 8, x plus 3. But you divide by 6. You reduce to fractions. Okay, 8 divided by 6 is 4/3. 3 divided by 6 is 1/2. And then you kick the denominator to the front. So you're going to kick the 3 to the front. Kick the 2 to the front. And so that is one thing we covered together. So like we might have time for one more. So here I would go 5 times 12. 60, add to negative 17. And then, what would that be? 60, that's easy. Negative 20 and 3. So negative 20 times 3. Oh. Well, that's not going to work. Because negative 20 times 3 is negative 60. We want positive 60. So let me play around with the numbers. They're going to have to both be negative. 60 divided by 4? No. 60 divided by 5? There it is. I'm glad I stopped myself. It's actually negative 5 and negative 12. Because negative times negative is positive, negative plus negative, in this case, is negative. So then I would have x minus 5, x minus 12, and then I divide them both by 5. Five divided by 5 is 1. 12 divided by 5 doesn't reduce, so I kick the 5 to the front. Okay. And then finally, here, I take 2 times negative 1, that's negative 2. Needs to add to negative 1. What multiplies to negative 2 but adds to negative 1 would be negative 2 and 1. So then I'd get x minus 2, x plus 1, and then I divide by that number. 2 divided by 2 is 1. 1/2 doesn't reduce, so the 2 kicks to the front. Okay, so now that we spent half our time reviewing how to factor, why are we doing all of this? Okay, so the point of doing all of this is so that we could solve a quadratic by factoring. Keep in mind there are other methods besides factoring, but usually factoring is the most efficient. And remember that the solution is found by setting the function equal to 0. Okay, y equals 0, that would be when y is 0, so that would be the x-intercepts. We're looking for x-intercepts. And we also call x-intercepts other things. We could call those zeros. You may also see these written as roots. You may also see these written as solutions, which is what they say. So we're going to use something called the zero product property. And this property is very useful for Algebra 2. And all it says is if you multiply two numbers, then one of them has to be 0. Let me rephrase that. So if you multiply two numbers and you get 0, then that means one of those numbers had to have been 0. So if this is a mathematical form, if two numbers multiply and get 0, then either A is 0, B is 0, or could be both are 0. That is the only way you can multiply and get 0. You have to have 0 as one of those numbers. So for example, if I were to get x plus 3 times x minus 5 is 0, then I need to figure out what number plus 3 is 0. Well, negative 3 plus 3 is 0. So that would be one of my solutions. And then, so that's how this would become 0. And then what number minus 5 is 0? That would be 5. 5 minus 5 is 0. 0 times anything is 0. So this is what we call factored form. If you have it in factored form, it's easy to find the x-intercepts. Okay. So for example, A, I am trying to find the x-intercepts, otherwise known as zeros, otherwise known as roots, otherwise known as solutions. So 4 times what numbers to the second power, and then you take away 9, do you get 0? Well, this one you can actually solve by using square roots, but I'm going to show you solving by factoring. We're going to factor this. This is difference of 2 squares. So that would be 2x plus 3, 2x minus 3. And then by the zero product property, if you're taking 2x plus 3 times 2x minus 3 and you get 0, that means that 2x plus 3 is 0 or 2x minus 3 is 0. So from here, I could say 2x plus 3 equals 0 or 2x minus 3 equals 0. From there, this is algebra 1, solving for x. I would subtract 3 from both sides. And then I would divide by 2. So I get negative 3/2, which is negative 1.5. And then the other one, if I solve for x, I would add 3 to both sides. Divide by 2. And I get 3/2. So I can say my solutions are x equals positive and negative 3/2, or positive and negative 1.5. Now let me show you real fast and another way you could have got this answer, and it's the way I would recommend to check your work. So if you go out to Desmos and you type this in, we could go and see the x-intercepts are negative 1.5, 1.5. Okay, so this is a very easy way to check your answer to see what the x-intercept should have been, and that's exactly what I just got. Now, if you want instructions on how to do it on the TI-83, I have these in the notes. They walk through what buttons you push, and so the thing is, on the ACT, you could use the TI-83, which is instructions here, and you cannot use Desmos. So it's good to know how to use the 83 calculator. All right, let's do another example. And I'm going to separate these so they don't get confused. There we go. X squared minus x. Well, whenever I see two terms, I usually start thinking difference of 2 squares. X squared is a perfect square, x and x. X isn't a perfect square. And it doesn't have 3 terms. So what else is out there? Oh, GCF. So if I look at this, and you should always be looking for GCF, x squared and x both have an x. So I would factor out an x. And what am I left with? X times what is x squared would be x. X times what is negative x, that'd be 1. And so now I have what's called linear factors. So I have x times x minus 1 is 0. By the zero product property, in order to multiply 2 quantities and get 0, that means either x is 0, which is my first multiplication, or x minus 1 is 0. Now x equals 0 is already solved, so I'll put that here. And then what number minus 1 is 0? That'd be 1. So the other answer is 1. To show my work, I could add 1 to both sides, and you get x equals 0 plus 1, 1. So that means if I were to go graph this, they cross at 0 and 1. X squared minus x equals 0. Crosses at 0 and 1. Okay. All right. Now let's do a tricky one. Oh, another way you could check your work, and I'm not sure why I didn't mention this. When you plug these back in, they should work. So like if you think about it, 0 squared is 0, and then 0 minus 0 is 0. And then 1 squared 1 times 1 is 1. 1 minus 1 is also 0. So when you plug in these numbers, like if I plug in 3/2 into x, I should get 0. When I plug in negative 3/2 for x, I should get 0. So that's another way to check your answer. 4 times what number squared minus, you take 14 times that number, then you add 7, do you get 4 minus 0? 4 minus x. Okay, this is about as tricky as it's going to get, and I did this on purpose for our last example. In order to solve these, you want equal 0. The reason why you want equal 0 is so that you can use the zero product property. If you don't have equal 0, then you cannot use the zero product property. So the first thing I'm going to do is I'm going to move everything to one side so that 0 is left over, because there's always nothing. So I'm going to go minus 4 from here, minus 4. And then I would also add x to both sides. I could do two things at once. And so from there, I'd have 4x squared. And then negative 14x plus x would be negative 13x. And then 7 minus 4 would be 3. And nothing's left over there, so I put 0. So all I did was I subtracted 4, added x to both sides to get nothing over there. Now from there, I'm going to factor. I look for GCF. 4, 13, 3 are all relatively prime. A is not 1. We have a quadratic trinomial, 3 terms. So I'm going to do the x. And I'm going to multiply 4 times 3 and get 12. And I'm going to pull down the negative 13. And I'm looking for two numbers that multiply to 12, but add to negative 13, negative 12 and negative 1. Yes. From there, I'm going to put x minus 12, x minus 1. But just like we just reviewed, I need to divide them both by 4. And then see if they reduce. If they don't reduce, then you slide or kick, however you want to say it. 12 divided by 4 is 3. So nothing kicks there. But 1 over 4 is reduced, so I kick the 4 to the front. Okay. So now I have the product of two things, x minus 3 and 4x minus 1. We have the product of these two terms, quantities. So if I multiply these two and I get 0, that means either x minus 3 is 0, and I have to borrow space from the bottom of the page, or 4x minus 1 is 0. Well, what number minus 3 is 0? That'd be 3. So one of my solutions is x equals 3. Because if you add 3 to both sides, you get 3. And then I could do these in my head. And so the way I do these in my head is I think of the opposite number here, so it'd be 1. And then I divide it here, so it'd be 4. So I could look at this and go 1/4. And after you do this a while, you'll start getting fast at that too, because you're going to add 1 to both sides and then divide by 4, so that'd be 1/4. And if you're able to skip this step, that's fine, but showing my work, I would add 1 to both sides. I get 4x equals 1, and then I would divide by 4, and I get 1/4. So when I plug this in, I should get a true statement. Now let's go see what this really looks like. So the left side of the equation looked like this. We had 4x squared minus 14x plus 7, which was a quadratic. The right side was a line. It was y-intercept of 4 with the -1/1 slope. And so what we're really looking for is we're looking for when does this parabola cross this line. And if we go here, look, we got 0.25, which is one of my answers. And we also have 3, which is one of my answers. And so you may be thinking, wait a minute, you said the solution is where it crosses the x-axis, and that's true. However, in this case, we didn't have equals 0. Okay, so you could just graph the parabola and then graph the line and see where they intersect. Now what we decided to do, instead of looking to see where a parabola intersects a line, we put everything on one side. And now we could look for where it crosses the x, which again is 0.25 and 3. So that's 2 different ways of thinking about it. So if I plug 3 in here, I would get 0 because 3 squared is 9. 9 times 4 is 36. And then 13 times 3 is what, 39? So I got 36 minus 39 is -3. And then you add the 3, you get 0. All right. Well, just my last reminder, if you have a TI-83 at home, I highly encourage that you read through these notes. There's a video that goes through it too. Right here, this video walks through how to use the TI-83. And then what I want you to work on for practice solve by factoring, check your answers. How do you check your answers? You could use Desmos or you could plug back in. Just make sure you have the right answers. And then on 9 through 14, I'm giving you permission to solve by graphing. So you could just use Desmos or the TI-83. Again, if you have a TI-83, I encourage you to use it because that's what you can use on the ACT. So a lot of these answers aren't going to be whole numbers, so round to 2 decimal places. So like 3.27 would be 2 decimal places. Other than that, we did great on time. I'm going to sign off and see you guys here in a half hour if you have questions, or I guess right now. Bye, guys.